Okay, let's write the ionic and net ionic equations for the reaction between hydrofluoric acid and sodium hydroxide to make sodium fluoride and water. Remember the rules are we're going to split up into ions any ionic compounds that are aqueous and any acids that are strong acids, part of our big 7 acid list. Let's begin. So I start with HF. I notice that HF starts with the letter H. That's the clue to me that this is an acid. When I look at my list of 7 strong acids, I notice HF is not on it. Therefore, HF is not a strong acid. Do not split it up. In fact, out of all the acids your professors are probably going to try to fool you with and see if you split up, hydrofluoric acid will be one of them, and acetic acid, HC2H3O2, is probably going to be the other. Do not split these two up. It's not a strong acid. It's not ionic. H is not a metal. So we leave it alone. I'm just going to go ahead and rewrite HF. Then we go to the next substance, sodium hydroxide. Sodium hydroxide starts with the metal sodium, and we have a polyatomic ion. It is ionic, and it does say aqueous. So we need to split sodium hydroxide up into the positive ion and negative ion. The positive ion for sodium hydroxide is Na with a plus sign. And I'm going to go ahead and write the aqueous here. Plus, the negative ion happens to be hydroxide. Do not split the O apart from the H. Keep your polyatomic ions together. So I'm going to write OH minus, and then I'll write the aqueous sign. All right, let's examine our products. The first product, sodium fluoride, starts with a metal. We have a metal and a nonmetal. It's aqueous and ionic. So we know we're going to need to split sodium fluoride up into the plus ion and the minus ion. The plus ion is Na positive. The negative ion is F with a minus, and I'll write aqueous there. And then our last product, water. Water is not ionic. We do not have a metal with a nonmetal. Water is covalent, and water is not a strong acid. Therefore, we just need to recopy water down. Leave it alone. Do not split it up. So I'm going to just recopy my H2O as a liquid. That gives me this entire reaction, which is called the full ionic equation. It shows all the products and reactants in their dissociated or undissociated state. Now, if we want the net ionic equation that shows the actual players of this reaction, we need to try to find the spectator ions, the ones that did not react, the ones that are exactly the same on the left-hand side of this equation as they are on the right. When I look for things that are similar, I see sodium plus on the left and sodium plus on the right. I can go ahead and cancel those out. Now, it's true that I see an F on the left and an F on the right. However, they're not exactly the same, and therefore you cannot cancel those out. This F is attached to an H. This is the F minus ion. Those are not the same. So in this particular example, we only have one spectator ion. If we rewrite what's left over, we get hydrofluoric acid aqueous plus a hydroxide ion that's aqueous. This forms the fluoride ion in its aqueous state and water as a liquid. Now, this is our net ionic equation. If we look at this net ionic equation, what we see is that the hydroxide pretty much came in and replaced or bumped out the fluoride ion to make water. If we want to do a double check of this net ionic equation, let's make sure that our elements are balanced and our charge. So for elements, 2 hydrogens on the left, 2 hydrogens on the right, 1 F on the left, an F on the right, and 1 oxygen on the left, 1 oxygen on the right. Similarly, let's check our charge. No charge and a -1 makes a total of -1 on the left. No charge and a -1 makes a total of -1 on the right. Our net ionic is balanced by both elements and by charge. Hope that helps.